Okay, so let's get started. In our last lecture, we talked about the linked list implementation of. This is going to be lecture 11, I guess. Okay. Okay, so in our last lecture, we talked about the implementation of linear lists, and the way we implemented those linear lists was through a singly linked list. Okay. So we talked about linked list, what do we mean by linked list, and we talked about what is a singly linked list. So if you remember, a singly linked list is basically a linked list in which all the nodes that we have, they have a single link to, or they have just one link to another node. Okay, so they are linked to just one node. They are linked to just one node. So that is a singly linked list in which each node is linked to just a single other node. So such a list is a singly linked list. And how do we create that link? We created that link by using a pointer. Okay, we created that link by using a pointer. So we have this is a doubly linked list that you're looking at right now. This is a doubly linked list. In a singly linked list, we had these nodes, and each node had two fields. One field stored the data, and the other field stored the address of the next node. Okay, and so this was a pointer, and it stored the address of the next node, and that pointer basically created this link or established this link between these two nodes. Okay, so say this is another node. So this was a singly linked list. Each node had two fields. One field used to store the data, the other field stored the address of the next node. So this was a pointer variable which stored the address of the next node, and this storage basically created this link. It linked these two nodes. Similarly, this node stored the address of the next node, the node that followed this one, or the node to the right of this one. Okay, so say this is the next node, and it has this data, and if it is the end of the list, it stored a null pointer. It did not have any address, so it did not point to any other node. So there was no link after that. Okay, so there was no link after this was the end of the linked list. So this is how we implemented singly linked list. So singly linked list is it has its own advantages and disadvantages. So as compared to the array-based implementation of linear lists, so the linked list representation has this advantage that you can, like its size can vary dynamically. When at runtime, you can start with an empty linked list that does not occupy any space in RAM, except for its two attributes: the pointer that points to the first node in the linked list, the first pointer, and the integer variable which basically points to stores the list size. So except for those two attributes, there were no nodes which were basically part of this singly linked list. Okay, so we started with an empty singly linked list, and then we started inserting nodes into that list, and then we ended up with a populated linked list. So this is what we created last time. This is the code that we wrote last time. Let's see, let us open that code. So this was a singly linked list that we created last time, and this was the interface of that list. Okay, so here we are, say, inserting. Here we created the singly linked list. So right now it is empty. If you get its length, it would be 0. Uh, and then we start inserting nodes into this singly linked list. We started calling the insert method of the singly linked list object. Okay, so we started inserting these new nodes, and then we started printing, say, the updated list, and after inserting, say, around 10 nodes, we and all these nodes were inserted at the 0th position after the 0th node. Okay, so that means the first position in the list. So all these nodes were inserted in the first position in the list, and then we inserted a node in the middle of the list after, say, k is equal to 5. So at 6th position in the list we inserted a new node. You can change it. Say let us insert a node at the 8th position, and then we want it after the 8th position, sorry. So after inserting this node, we checked out how does the updated list look like, and then we deleted a certain node. We deleted the 8th node. Let us try deleting, say, the 6th node, and then let us look at the updated list. Okay, so this is what we wrote last time. This is what we created last time. Let us build and run this code. So this is what we have. This is we start with the with an empty list initially. If you look at the code, this is what we do. So we create this list SL, and initially it is an empty list. So you see in the constructor, when we instantiate the list, it does not have anything. The first pointer has the value 0 or null. It points to nothing, and the list size is 0. That is what happens when we create a list. So it is an empty list. It does not have anything. So that is what we print. That is the information that we print. We get its length, and that length is equal to 0. So we know that it has nothing. And then what do we do is we start inserting data into the list. We start inserting data into the list. Okay, and that data is basically I square plus 2. Okay, so that is what we do, and once we start inserting data into the list or new nodes into the list, so then we print the updated list. Okay, so then we print the updated list, and that is what you see here. So after, say, the first node is entered, that is for I is equal to 0, so I square plus 2 is 2. So you have 2 here, and then the new value is entered at the beginning of the list after k is equal to 0, which is the position number 1. So every new entry, it appears at the beginning of the list, and the old entries are pushed downwards, okay, or pushed towards the right. So after inserting 10 entries, this is what we have. Size of SL is equal to 10. So this is the list that we have, and that is it has these 10 elements. Okay, then what do? We want to insert a new node after, say, position k is equal to 8. So this is position number 1 in the list. 2, 3, 4, 5, 6, 7, 8. So the new entry 1000, it is inserted after this position k is equal to 8. So it appears at the 9th position. Now the list has 11 elements, and then we want to delete the 6th element, and then we want to print the updated list. Okay, so if you look at this list, the 6th element is 1 2 3 4 5 6 18. So we delete 18. Once you delete 18, so then after 27, 11 would appear, and that is what happens. Okay, so in this code I want to demonstrate something else as well. And what is that? Like, if you look at these two functions or methods, the insert method and the delete method, it returns pointer to the singly linked list in which we inserted the new node or from which we deleted the new node. Okay, so we are getting pointer to the singly linked list. Now you can use this pointer. So let me show you how can you use that pointer. Okay, let me show you that. So let me comment out this thing. Let me comment out this thing as well. So once we insert a new node, so the return type of this insert function is basically a pointer to the singly linked list in which we inserted that node. If you look at the insert function, where is the insert function? Here we have the insert function. So at the very end of the insert function, we are returning this pointer. So that means we are returning pointer to the object for which this method was called. We are basically returning pointer to an object for which this method was called. So once this method is executed, so we have a pointer here. Okay, we have a pointer here, and we can use that pointer. Okay, so s1.insert, it returns a pointer. Okay, and that pointer is pointer to a singly linked list object, so I can use that pointer. With a pointer I have to use the member access arrow member access operator, so I can use this pointer to invoke some method on this object. So I can say print. Okay, so I can do the insertion and printing in a single line. Okay, so I can do that, we can do that. Okay. Okay, so I hope like it makes sense to you. Okay, so let's do that. Let's see if it is fine, if we can do that. So let us build and run it. So now you see like we insert to the first data element, and then we print that list. So then we insert a new element, and then we print that list. Now we don't have the updated list, and we are not calling the s1.print method like that, but we are using the pointer that was returned by s1.insert to call another method. Okay, so that is the benefit of doing that, of returning this pointer. Okay, now let us look at something else as well. Let us look at something else as well. So I'm commenting this line as well, and let us say I want to do s1 dot insert. Okay, s1 dot insert, so we are inserting a new node at after position 0, and we want to insert data there. Okay, now the insert method returns as a pointer, okay, to the linked list in which we just inserted this new node. So let us use that pointer. So I'm using the arrow member access operator with it, and I'm re-invoking the insert method. Okay, so I'm calling the insert method twice uh, in a single statement. And here say I want to insert this value, data times 2, 2 times the data. Okay, and this insert method would also return me a pointer to the singly linked list for which we call this method. So let us use that pointer to print the updated list. Okay, so this is something that we call a cascaded function call. This is something that we call cascaded function call. We made a call to one function. That function returned us a pointer to this object singly linked list. Using that pointer, we made another function call, and that function call returned us another pointer to the singly linked list object, and using that pointer we made another function call. Now the print function, it returns void or nothing, so we cannot make any further calls after this call. Okay, but you should remember like if some method is returning you this pointer, so you can always use that pointer to invoke any of these other methods. Okay, you can always use it for that. Now within this loop we are inserting two nodes. For each execution of this loop we are inserting two nodes. So this loop executes 10 times. So after this loop is done, we would have inserted 20 nodes into the list. Okay, although it would be printed just 10 times, it would be printed just 10 times because we are calling the print function only once, and every time the print function is called, the size of the array would have grown by 2. Okay, so let us build and run it. What does it say? So this is not S1, this is SL. That's why we didn't get this thing. So you should use names carefully. This was a poor choice. It is a little confusing. I keep on forgetting it. So let us build and run it again. So this is what we have. Now we are first inserting say 2 and then 2 times 2. So the first call to the insert method, it inserts 2. The second call inserts 2 times 2, which is 4, and then we print the list. Okay. So just this one statement, it does these three things. It inserts 2 into the list, then 2 times 2, 4, and then it prints that list. Okay. The next call, it inserts 3 into the list, and then 2 times 3, 6 into the list. Then it inserts the next call inserts 6 into the list, and 2 times 6, 12 into the list, so on and so forth. So now the list has say 20 elements. If you insert after k is equal to 8, this is how the list would become, and then you can delete. We can delete an element, and after doing that, this is how the list appears. Okay. So this code works. It can work in this way as well. Okay. So you should remember this. This is what we call as a cascaded function calls. These are cascaded function calls. So after one call, this is a cascade of function calls. After this function call comes out this function call, comes out this function calls. That is why we call it a cascaded function call. Okay. This is what we did last time, and this is how we implemented singly linked list. Now, one of the disadvantages of singly linked list was that once if you are at this node, you don't have any information about the previous node. Okay, so you don't know which node is toward behind you or to the left or previous, which is the previous node. You don't have that information. You only know about the next node. Okay. Now that can at times complicate things, like if you remember when we were inserting a new node or deleting a node, so we needed to have information about two nodes. But if you have a doubly linked list, this is what a doubly linked list is. Okay. Now in a doubly linked list, we have two links. Every node knows which node is in front of it and which node is behind it, or which node is next to it and which node is the previous node, or which node is to its right or which node is to its left. Okay, so we can use all these terminologies. It doesn't matter which terminology do you use, whether you use left or right or next or previous or top or bottom or any of these terminologies. These are fine. Okay, as long as you are consistent. So you should be consistent. So in a doubly linked list, we have every node. This node is different than the node of a singly linked list. In the node of a singly linked list, we had two fields. One field was used to store data, and one field was used to store the address of the next node. In the doubly linked list, the double node, okay, it has three fields. One field is used to store data, one field is used to store information about the next node, and the other field is used to store information about the previous node. Okay, so every node knows which node is behind it and which node is ahead of it. Okay, so it has this information. Now this information, it comes at the cost of an extra pointer. Like every node has an extra pointer, but this information can be useful and it can speed up things. It can speed up things, and it gives you the advantage that now you can traverse through this list from left to right and from right to left. Now you maintain, the doubly linked list maintains pointers to both the front and the back, or the left end and the right end of the list. Okay, or the front and rear of the list, or the header and trailer. So these are all different terms. Okay, front, back, left end, right end. Let me write the other terms. So header, it is also called header, uh, header, and this one is called trailer, something that trails. ट्रेलर जो होता है इंजन के पीछे जो लगा होता है, ठीक है. So this is the trailer. अच्छा, it is also called front and rear. These terms are also used. and again, like which end do you need to call the front and which end do you need to call the rear? That is also arbitrary. It depends upon you. You can call this one as the front and this one as the rear, but again, the important thing is that you should be consistent. Okay? So this is the doubly linked list. It's simple. It is a linear list. Like all these elements have that relationship: E1, E2, E3, En. E1 comes first, E2 comes after that, E3 comes after E2, E4 comes after E3, En is the last element. So it has all these that relationship, but the way we implement that list, it is different. Now we are using nodes which have two links. Each node knows the node to its right and the node to its left. It has addresses of both those nodes. Okay, so we can use doubly linked list to represent or implement lists. Okay. Acha. So in a doubly linked list, we have the double node. Okay, now we have this node is different. In the singly linked list, I guess we only had node. I don't remember what did I name it, but I guess it was only node. If we can look at this thing, so here we only had a node. Okay, so this was a simple node, and this was the node of a singly linked list. So now we need a different node. We need a new class that would be a double node, and the double node will be this node. It will have three fields: one field to store data, and one field to store the information about or addresses of the left and right node, okay, or the next and previous nodes. So we can also use these terms as well: next and previous, left and right, next and previous. Have we mentioned these here or not? So left and right, next and previous. Okay. So we can always call them as uh, let me add that in the comment, next and previous. Okay, so you can find these different names being used for the nodes that come before and after a particular node. So this is how the double node would look like, and we will add the doubly linked list class. We'll specify the doubly linked list class as its friends class, as its friend class. Okay, that is what we are going to do. Acha. Now this is how the double node class would look. We would write code for it so you would know about it. Similarly, the double node, the doubly linked list class that we are going to implement. Okay, this is classed doubly linked list. Let me write it here. Linked list. Okay. So this is the doubly linked list that we are going to implement. Okay. Now this is slightly different. I like what we should have done is we should have implemented this interface. This was the interface of the singly linked list class. The only things that we needed to replace here was like we should have a doubly linked list constructor here, a destructor for the doubly linked list class. Then is empty, length, find, search, delete, insert. These should have remained the same. Okay? But I guess we have implemented this interface once. So I am leaving this to you. So you should implement the same interface, the same methods or the same behavior for a doubly linked list class. So the only difference would be that this would be a doubly linked list class. It will have different data members, and it will have these constructors and destructors that would be named according to the class, doubly linked list class, and the rest of the interface it would remain the same except for this return type. This would be a doubly linked list. Okay, so I want you to try this. Here I'm going to implement a different interface. So this is another interface, and this comes from another book. Like this interface for a linear list is followed in the book by in the book Data Structures, the book on data structures by Sirtaj Soni. And this one, I guess this one comes from Michael T. Goodrich and Roberto Tomasia. So I'm going to implement this interface. So this will give you basically a taste of both interfaces. So you would know how to implement like both these interfaces, but you can always do that using doubly linked lists. Okay, so that should not be a problem. So in this session I'm going to implement this version of the doubly linked list class. Okay, so let's get started. Let us close this project and create a new one, and here we are going to create a project on doubly linked lists. Okay, so this is going to be the title of our project, doubly linked list. Okay, so we are going to implement a different interface for the list, and this interface is not like the one that we talked about in our last lecture. This is slightly different. So let me add a header file in which we'll specify the interface. So this is going to be our header file. Let us specify कि इसको कहाँ पे store करना है. So we want it in the same directory as the remaining files of this project. So here we have our header file. So let us declare our classes. So the first class is double node. Okay, double node. So double node mein what do we need to specify? All the data members here. This is what double node should look like. Okay, so first of all we need to specify these fields. What are these fields? These fields are as follows. One field we need to store the data in data, and the other fields, two fields, are pointers to the previous node and pointer to the next node. So you can go with the left or the right, okay, if that is convenient for you, or you can go with the next and previous, okay. So both are fine. So we have three fields. Each double node knows about the node that comes after it and the node that uh, came before it. So it knows both about, it has the addresses of both the successive node and the node that just went, the predecessor, the successor and predecessor. It has information about both of them. And we also need to declare the doubly linked list class as its friend class. Doubly linked list. So this is going to be its friend class. Okay, and let us see what the doubly linked list class would have. So this is how the doubly linked list classes interface would look like. So first of all we need to declare its data members. So we want to store its size in the variable list size. I didn't specify this, I guess, in this slide, but we should have it. We should have one data member which would be an integer. Okay, int, and this would be list size. Okay, acha. And here we have double node. This is short D node, but here we have double node. I name them header and trailer. You can name them differently. Okay, so then we have double nodes, pointer to double nodes, and those nodes are, so you can pick any name from this figure. So you can call them left end or back end or front or back, or header or trailer. Header is what comes first, trailer is what comes last. Okay, you can call them first and last as well. First and last, you can call them any name, but you should be consistent. Okay, so we can call them front and back. Let us call them front and back, say for example, or left end and right end. So you can name them like anyway. So let us call them front. So, or let us stick with header and trailer. Header and say, sorry, header and trailer. Okay. So header is the first node in the list, trailer is the last node in the list. That you should remember, or you can add it as a comment here. Header is first node, okay, and trailer is last. or you can like go with these names, first and last. You can call them as first and last. Again, these are arbitrary choices. Okay, you can do whatever you want, but you should be consistent and these should make some sense. Okay, so first and last, you can name them like this: first node, last node. Achha. Now we need to define the specify the public interface. So it must have a constructor. Doubly linked list class must have a constructor. Let me copy this name. I'll be needing it a lot. And this is the constructor. Okay. In fact, let us copy things from here. Here I have specified the interface. So let me copy these things here from here. Okay. So let me paste those names here. So this is the destructor. This is the isEmpty function. Get front. So it will basically return the value in the first node. Let me change their names as well. So let us call it get first. Okay, so it will return the data stored in the first node. First, this let us make it get last. Get last. Okay, so we are getting the last node. Add front. Okay, add front. Add at first. That would not. ठीक है ठीक है ये नाम ठीक है add at front, add at back, ठीक है, और end. So add at end. So we are adding a new node at the end. We are adding a new node at the front, and this is going to be. You can specify data, ठीक है, or a new node. Let us make it. Let us try it this way. Okay, so this would be. This would be say a new node. Okay, double new node. Sorry, double node. This is double node. Okay, double node, new node. So let us try it this way as well. Add at end. So this would be pointed to a new node. Double node, new node. Okay. Acha. Remove first. This would make sense. Remove the first node. Remove the last node. Okay. Acha. These are easy to implement, you'll see. And traverse forward. Okay. Forward means from first to last. Traverse backward from last to first. Okay. And this traversal would mean that we need to visit each node and print the value stored in that node. Okay. So that is what we would do. Okay. So this is the declaration of our doubly linked list class, and now let us implement it. Okay. Acha ji. So I'm copying these declarations. Then I need to add, in fact, we need to add a new source file in order to define these functions. So let us store that source file in the same directory. Name it as my classes.c++ and include it in the debug and release versions of the project. Add to the project. Okay. And here we are. Okay, so here we are going to define those functions, those member functions of the doubly linked list class. So let me include the header file which has the definitions of these declarations of these functions. Then let us include, we might need to do some printing. So let us include the IOStream header file. Sorry. And we are going to be using namespace standard. Okay, so these are the functions that we need to implement. This is the constructor, and this is basically the constructor of the doubly linked list class. Okay, so let us do the scope resolution, and let us copy this thing. We'll need to paste it over and over again. This is the destructor, and this is the isEmpty function. This here get first would return the data stored in the first node. This would return the data stored in the last node, assuming that there is data in that node. This would be, so that is why, like, you should not be, ideally you should not be returning an integer value. You should be returning a boolean value, because if the first node is empty, if there is no data in the list is empty, then what should you do? Like, then you should return a boolean value, false. Okay, you should let the user know that there is nothing in the list, and the value should be returned by a reference here. Okay, so we need to change this. This is not a good way to implement it, but let us first make these changes, and then I'll change that as well. Okay, so this is removed first, and now if you look at this implementation, this is slightly easier. We are not doing remove the kth position, and we are not doing addition after the kth position. Okay, so we are not going by the implementation of that standard list interface, linear list interface. So this is a slightly easier interface, but I wanted to show you this interface as well. Okay, so let me, although like this is a lot of labor for me, because I have to rewrite an entirely new class. In the other case, what I could have done was I could have made changes into the singly linked list class, and then we would have ended up with a doubly linked list class, and that would have been very easy. Like, it would not have been very difficult. But I guess you should also be able to do that. Like, you can implement the same interface that we had in the doubly linked list class, and you can implement it using doubly linked list. Okay, so the linear list interface that we had in the standard interface for the linear list, you should implement that with the doubly linked list class. Okay. Acha, so here I wanted to say, like, get first, get last. It should be returning a boolean value. Okay, it should be returning a boolean value, and that would mean whether there was whether the list was non-empty or not. Okay, and the data should be returned here. We should pass it a reference through which we can basically send back the data to the calling function. Okay, so this is a better implementation, because what if a user calls this method get first and get last for an empty doubly linked list? So what would happen then? Then definitely an empty list won't have any data, so we won't have any value to return. But in this case, we would have a false value to return if that is the case. Okay, so let us change these definitions here as well. Get first, so this would be a boolean value. This would also be a boolean value, and this would be the variable through which we would return the data. Achha. Now let's see. Now this is also not a good way to do it. We should only get data, and we should not be getting pointed to the double node. Why? Because we need to modify the attributes of this new node, and we don't know whether the user would pass us a constant pointer or something that we would be able to change, so we don't know that. So this should also be just data. Okay, so it should be data. Let us make it that way. Okay, इसमें there is nothing very strange or difficult about it. What we'll do is, like, इसमें हो ये रहा है कि main program में you are creating the node and passing its address here, but that is not the best way to do it. So what we should be doing is we should get the data like this, const int, ठीक है, and data. So we should get it like this. We should not be able to modify that data, and just we should insert that data into a new node, create a new node and insert that data into that node. So let us do that. Okay, and this function is not returning anything. Okay, the added friend added, and it is not returning anything, but it can return. So just like the way we did it there. So we used to return the insert function and the delete functions. They used to return pointer to the singly linked list, and then you could use that pointer to make cascaded function calls. We are not doing that here, but ठीक है, वो आप कर सकते हैं. You can always do it. So let us start implementing these functions. First is the constructor. So beginning in the when a user creates a doubly linked list, it is going to be empty. So the first and last, ठीक है, the first last these would be null. So first would be null, and last pointer this would also be null. So the list that we are going to create, it's going to be empty, and the first the pointer to the first node is going to be null. The pointer to the last node, that is also going to be null or 0, and the list size, it is also going to be 0. Okay, so all these attributes are going to be 0. It is going to be an empty list with nothing. Okay, what about the uh, what about the what? What about the destructor? So the destructor, it's going to destroy all the nodes in the doubly linked list. Okay? So if first is not equal to 0, that means the list is not empty, and that means that you need to visit each list, each node, and then destroy that node. And before destroying that node, you should go to the next node. Okay? So we'll do it the way we did it in the case of the singly linked list. Okay? So how are we going to do it? So in order to visit or traverse through the list, we need that variable current. Okay? So double node, it's going to be pointer current, and let us set current to first. Okay? अच्छा जी. And then we need another pointer for the node that we are going to delete me. Okay, let us call it delete me, and let us set it to current or first. Okay. So what are we going to do? While current is not equal to null, while current is not equal to null, when it becomes null, then this loop would stop executing. That means we have destroyed all the nodes in the list. So while current is not equal to null, what are we going to do? So we are going to set current equal to current arrow next. So we are going to point to the next node. Acha, this is what we are going to do, and we are going to delete the node delete me, जिसका एड्रेस हमने delete me में स्टोर किया हुआ, and the next node जिसको हमने delete करना है, तो that is basically उसका एड्रेस current में stored है, current is equal. इसके बाद वाला जो next नोड है इसको हमने नेक्स्ट टाइम डिलीट करना है, ठीक है। So let us apply this code to a sample doubly linked list, ठीक है। So let us see, say for example ये हमारे पास doubly linked list है, this is the front node, ठीक है। So ये कोड क्या करता है, it starts here. So current is a pointer, we assign the value first to it, and similarly delete me is a pointer, we assign the value current to it, ठीक है। So at the very beginning current also points to this node, and delete me वो भी इस node को point कर रहा है, and this node इसका जो address है it is not 0, so this condition would be true, it is not equal to 0, so we are going to enter this loop. So वहाँ पे हम क्या कर रहे हैं, वहाँ पे we are modifying the current pointer, ठीक है। वहाँ पे we are saying कि current जो कि इसको point कर रहा था, now current would point to this node, ठीक है। इस नोड का एड्रेस हमारे पास डिलीट मी पॉइंटर में पड़ा हुआ है, सो वी डिलीट दैट दिस नोड, इसे डिलीट दिस नोड, तो इसको हमने डिलीट कर लिया। और फिर नेक्स्ट जो नोड जिसको हमने डिलीट करना है वो ये वाला नोड होगा, तो इसका एड्रेस करंट में मौजूद है, हम डिलीट मी पॉइंटर में उस एड्रेस को कॉपी कर देते हैं, ठीक है। So that is what we do, and these are the steps that are going to be repeated. So next time we come here, current is not equal to 0, we say current is equal to current error next, this is the next node that we are going to delete. डिलीट मी में इस नोड का एड्रेस स्टोर्ड है, हम इसको डिलीट कर लेते हैं, और फिर नेक्स्ट जो नोड डिलीट होगा वो ये वाला होगा, तो हम इसका एड्रेस करंट में है, हम इसको डिलीट में कॉपी कर देते हैं। नेक्स्ट टाइम व्हेन वी एंटर द लूप करंट में इसका एड्रेस है इट इज़ नॉट इक्वल टू 0, सो कंडीशन इज ट्रू, हम करंट को सेट कर देते हैं टू दिस नोड, और इसका एड्रेस हमने डिलीट में रखा हुआ है तो इसको हम डिलीट कर देते हैं, ठीक है। और नेक्स्ट जो नोड जो डिलीट होगा वो ये वाला होगा, तो इसका एड्रेस हम डिलीट में पॉइंटर में कॉपी कर देते हैं, ठीक है। दैट दीज आर द स्टेप्स दैट वी रिपीट। अच्छा, तो फिर हम वापस आते हैं, हेयर करंट इज नॉट इक्वल टू 0, ठीक है। सो व्हाट डू, वी से करंट इज इक्वल टू करंट एरो नेक्स्ट, सो इफ यू सी हियर करंट एरो नेक्स्ट इज 0, इसके बाद देयर इज नो नोड, तो और इसका एड्रेस हमने डिलीट में रखा हुआ है, तो वी डिलीट दिस नोड एंड वी से डिलीट मी इज इक्वल टू करंट, तो डिलीट मी भी 0 हो जाता है या नल हो जाता है, तो करंट इज नल। सो नेक्स्ट टाइम व्हेन इट रिटर्न्स करंट इज नॉट इक्वल टू 0 वाली कंडीशन फॉल्स हो जाती है, ठीक है, करंट इज इक्वल टू 0, so we don't get into this loop and this function is done. So this is how we delete all the nodes in the doubly linked list, ठीक है। So this code should be familiar, this is what we did in our last session as well। अच्छा, ठीक है जी। नेक्स्ट हम क्या कर रहे हैं, वी आर सेइंग इफ इज एम्प्टी मेथड है, ठीक है, इज द लिस्ट एम्प्टी और नॉट। सो इसका अगेन वही सिंपल सा काम है, रिटर्न। अच्छा, इफ फर्स्ट इज इक्वल टू नल, अगर फर्स्ट नल के बराबर है दैट मीन्स the list is empty. If it is not, that means the list is not empty. So this is basically a relational statement. We are comparing first, which is a pointer, to 0, which is supposed to mean null, ठीक है। You should not be using 0, ये अच्छी आदत नहीं है, but this is for shortcut. You should be using the null pointer, the null constant value, NULL, capital NULL. That is what you should be using, ठीक है। In order to save some time, this is how I'm doing it. Acha, so this is what it is, ठीक है। If this condition is true, it would return true, list भी empty होगी। If this condition is false, it would return false, मतलब list empty नहीं है। अच्छा, now we want to read the value stored in the first pointer, ठीक है। So for this we need to be sure कि first is not equal to 0. So if first is not equal to 0, मतलब there is a node there, ठीक है, और null, first is not equal to null, then what should we do, फिर हमने ये काम करना है, हमने x में वो वैल्यू रिटर्न करनी है जो कि फर्स्ट में स्टोर्ड है, फर्स्ट नोड में, x is equal to first arrow data, ठीक है, that is what we should do, and we should return true, ठीक है। So this operation was successful. There was a node in the first position and we read the data stored in that node and we return true value. Else you don't need to do anything else, just return false. Okay? So else return false, that is what you should do. And similarly, this is what we should do here as well. This is what we should do here as well in the case of last. So if last is not equal to 0, last is not equal to 0, and there is a node at the last position, then we should copy the data stored in there into the variable x. So x is equal to last arrow data and return true. Else if that is not the case, then we should return false. ठीक है? अच्छा ये हो गया. Next we need to add a new node at the front. ठीक है? We need to add a new node at the front. Which is the node? We have the data for that node. ठीक है? So let us do that. So how can we do that? We can say double node new node is equal to new double node. ठीक है? New double node. Okay, so we created a new node and let us store this value into the data part of it. So let us say new node arrow data is equal to data. We have copied this data into it. ठीक है? अच्छा, now this node has to be inserted at the front. So let us look, this is the front. So we want to insert a new node here at the front. So uska, what would be the implications? So let me show it here first and then we will do it there. Okay, so let me get a pen. Okay, so this is a new node and we want to insert this new node into at the front. So what are we going to do? How are we going to manipulate the pointers? So data जो भी है वो तो यहाँ पे आ गया. Now ये जो नया node है, this would become the new front. इसका मतलब ये है कि there won't be any previous node, so its previous pointer should be 0 and its next pointer should be the front node. ठीक है? तो ये front node it should be its next pointer. It should point to the next pointer here should point to the front node, the current front node. ठीक है? So this is what we should do first. We have created this node, initialize its data, so its previous node is 0 because this is going to be the front node. ठीक है? And this is going to be the new front node. So after this node the old front node would come. ठीक है? Or the first node. So this is going to be the first node. So इसके बाद वाला जो node है वो current first node होगा. So इस pointer को हमने modify करना है. We have to set it to the current first node. So once we have set these pointers, then we need to modify and we need to specify कि नया first node कौन सा है. ठीक है? So we need to change that pointer so that ये इसको point करे. ठीक है? That is what we need to do. So let us do it in code. So we created a new node. This is what we did. We initialized its data field to the data provided by the user. Then this would be the first node. So इससे पहले there won't be any node. So इसका जो previous node होगा that would be null. And अच्छा. And इसका जो next node होगा that would be the current first node. मौजूदा जो first node है वो इसका current node होगा. ठीक है? मौजूदा जो first node है that would be its next node. अच्छा. And there is one more thing and that is कि ये जो मौजूदा front है इसका previous node 0 है. ठीक है? मौजूदा जो front node है उसका previous node 0 है. ठीक है? So फिर क्या करना चाहिए? तो इसको भी modify करना है. This node should point to ये जो नोड है इसमें इसका जो प्रीवियस नोड होगा वो ये नया नोड होगा, ठीक है। इस नोड का प्रीवियस नोड ये नया वाला नोड होगा, सो इट शुड पॉइंट टू दिस नोड, ठीक है। इट शुड पॉइंट टू दिस नोड, सो वी हैव टू मॉडिफाई दिस पॉइंटर एज वेल। अच्छा, so let us do that as well. Before changing the front, let us do that as well. अच्छा, तो नए नोड के तमाम फील्ड्स हमने इनिशियलाइज कर लिए, दिस इज करेक्ट। अब नए नोड को इंसर्शन से पहले जो मौजूदा फ्रंट नोड है हमने उसके प्रीवियस पॉइंटर को भी मॉडिफाई करना है, ठीक है। सो फ्रंट या फर्स्ट नोड जो है, सॉरी, फर्स्ट एरो previous, this would be our new node, ठीक है। front arrow previous, this would be our new node। अच्छा, इंसर्शन के बाद हमने लिस्ट साइज को भी इंक्रीमेंट करना है, प्लस प्लस लिस्ट साइज, ठीक है। अच्छा, इसमें एक और चीज़ हम भूल गए हैं, भूले तो नहीं है लेकिन वी शुड रिमेंबर इट। वो ये है कि वी आर अस्यूमिंग कि द लिस्ट इज़ नॉट एम्प्टी, ठीक है। वी आर assuming कि the list is not empty, but the list can be empty as well, ठीक है। So if the list is empty, तब थोड़ा सा mechanism ज़रा different होगा, and if the list is non-empty तो तब मुख्तलिफ सूरत हाल होगी। So this code would work fine if the list is not empty, ठीक है। ये जो कोड है this would work fine if, in fact, हाँ, यहाँ तक जो कोड है ना यूँ समझ लें, this would work fine if the list is not empty। Look at this thing, ठीक है। So we would create the new node, initialize this data, its previous and the next। So this is fine, this is fine, ठीक है। अच्छा, now this code, it may not work। Why? If the list is already empty, then first would be a null pointer and you cannot call this method for the first point, ठीक है। So ये कब होगा? ये तब होगा जब list is not empty, ठीक है। So let us make that condition। So if the list is not empty, तो वो क्या condition होगी? if अगर list empty हो तो क्या हो? if first is equal to null, that means the list is empty, ठीक है। तो तब हमने मुख्तलिफ तरीके से ऑपरेट करना है, और अगर वो सूरत हाल ना हो तो तब हमने मुख्तलिफ तरीके से ऑपरेट करना है, ठीक है। सो एल्स इट वुड बी स्लाइटली डिफरेंट। अच्छा, इफ द लिस्ट इज एम्प्टी, तो ये जो नया नोड है ना उसके फील्ड्स तो हमने ठीक इनिशियलाइज किए, डेटा को, प्रीवियस को और नेक्स्ट को। सो नेक्स्ट वुड बी नल, फर्स्ट नल होगा, अगर लिस्ट एम्प्टी है तो फर्स्ट ज़ीरो होगा, नल होगा, सो नेक्स्ट वुड आल्सो बी नल, ठीक है। अच्छा, सो दिस थिंग इज़ फाइन। सिर्फ इस पोर्शन को सेफ बनाने के लिए कि इसमें कोई एरर ना क्रिएट, ना रिजल्ट हो, तो उसको अवॉइड करने के लिए, एरर को अवॉइड करने के लिए वी आर परफॉर्मिंग दिस चेक, ठीक है। क्योंकि अगर लिस्ट एम्प्टी होगी तो फर्स्ट वुड बी नल एंड देन फर्स्ट एरो प्रीवियस, सो दिस वुड रिजल्ट इन एन एरर, ठीक है। बट इफ द लिस्ट इज नॉट एम्प्टी देन दिस वुड बी फाइन। सो इफ द लिस्ट इज एम्प्टी, सो व्हाट शुड वी डू? अगर लिस्ट एम्प्टी है तो जो पहला नोड है ना जो आप इंसर्ट करने जा रहे हैं, दैट इज द फ्रंट एंड दैट इज द फर्स्ट नोड एज दैट इज द लास्ट नोड एज वेल, ठीक है। सो फर्स्ट भी ये नया नोड है और लास्ट भी ये नया नोड है, ठीक है। लास्ट इज आल्सो दिस न्यू नोड, ठीक है। सो फर्स्ट एंड लास्ट बोथ आर दीज न्यू नोड्स। अच्छा, रेस्ट ऑफ द कोड इज आई गेस फाइन, ठीक है। रेस्ट ऑफ द कोर्स कोड इज आई गेस फाइन। ये जो चेक है ये हमें सिर्फ नॉन एम्प्टी के केस में चाहिए होता है, यानी दिस कोड, इन ऑर्डर फॉर दिस कोड टू रन विदाउट रिजल्टिंग इन एनी एरर, वी नीड टू परफॉर्म दिस चेक, ठीक है। अच्छा, सो आई होप दिस इज फाइन, दिस इज फाइन। ऐड एट फ्रंट, ये काम ठीक है। अब ऐड एट एंड, उसके लिए इसी कोड को कॉपी कर लेते हैं, ठीक है। ऑपरेशन इज सिमिलर। पहले मैं आपको आई विल शो इट ऑन द स्लाइड लाइक हाउ वुड इट टेक प्लेस एंड देन वी विल डू इट हियर। So the first thing is कि if the list is empty, so then add at front and add at rear, it is one and the same thing, ठीक है। अगर list empty है तो जो node आप insert करने जा रहे हैं that becomes the first node and that becomes the last node, so उसमें there is no difference. But if the list is not empty, तो फिर क्या तरीक़ाकार होगा? फिर ये तरीक़ाकार होगा insert at end या at last। उसका तरीक़ाकार ये होगा कि this is the new node, ठीक है। तो पहले आपने उसके फील्ड्स सेट करने हैं। सो ये जो नया नोड है दिस इज बीइंग इंसर्टेड एट द लास्ट एट द वेरी एंड, ठीक है। सो इसके बाद देयर वोंट बी एनी नोड, सो दिस नेक्स्ट पॉइंटर शुड बी नल, ठीक। इसके बाद कोई नोड नहीं है, डेटा को आपने इनिशियलाइज कर दिया। अच्छा, इसका प्रीवियस पॉइंटर, इसका प्रीवियस नोड क्या कौन सा होगा? अभी जो करंट जो लास्ट नोड है दैट वुड बी इट्स प्रीवियस नोड, ठीक है। सो दैट वुड बी इट्स प्रीवियस नोड, सो वो इसका लास्ट नोड होगा। And similarly, before we make it the last node, यानी जब ये insertion complete हो जाएगी, so this would become the last node. But before we do that, what we need to do is we need to modify this pointer. अभी जो मौजूदा last node है, इसका जो next pointer है, it points to nothing. So after the insertion of this node, it should point to this new node, ठीक है? So we need to make this thing. And once this is done, then we need to declare that this is the last node. Then we need to make this declaration, ठीक है। So let us do that. यहाँ पे भी चेक करते हैं कि have we made that declaration of making it the first node। अच्छा, so else first arrow previous is equal to new node and then first is equal to new node। so नया नोड उसको हम first declare कर लेते हैं। ये सॉरी हमने करना है at end वाले में, at front में, insert at front में we have to declare the new first, कि नया नोड जो है वो हमारा फर्स्ट नोड है, ठीक है। अच्छा, तो हमने करंट जो फर्स्ट नोड है उसका प्रीवियस नोड सेट कर दिया टू द न्यू नोड एंड देन वी मेड इट एज द फर्स्ट नोड, ठीक है। ये जो काम, सो करंट जो फर्स्ट नोड है उसके प्रीवियस को हमने सेट कर दिया टू द न्यू नोड and then we declared the new node as the new first node, okay। so this is that declaration of the new first node because we inserted a new node at the front। अच्छा अच्छा, यहाँ पे हम क्या कर रहे हैं? यहाँ पे हमने insert at end करना है, तो पहले हमने इसके fields वो करने हैं। so new node arrow data is equal to data, that is this is fine। new node arrow next, this is going to be null, ठीक है। new node arrow next, new node arrow next, this is going to be null। new node arrow previous, ठीक है, this is going to be last। ये जो नया नोड है चूंकि ये हम इंसर्ट कर रहे हैं at the end of the list, so ये this would become the last node and इसका जो पिछला वाला नोड होगा that would be the current last node, ठीक है। अच्छा, तो पहले आपने न्यू नोड के फील्ड्स इनिशियलाइज कर लिए, जैसा कि यहाँ हमने कहा था कि पहले आपने ये फील्ड्स इनिशियलाइज करनी। देन वी नीड टू चेक कि लास्ट इज नॉट इक्वल टू ज़ीरो। अगर लास्ट इक्वल टू ज़ीरो है दैट मीन्स के द लिस्ट इज एम्प्टी, ठीक है। इफ लास्ट इज इक्वल टू ज़ीरो दैट मीन्स द लिस्ट इज एम्प्टी। सो देन फर्स्ट भी नया नोड बन जाता है, लास्ट भी नया नोड बन जाता है, ठीक है। अच्छा, इफ दैट इज नॉट द केस तो फर्स्ट सॉरी जो लास्ट नोड है उसका जो नेक्स्ट नोड होगा वो हमारा नया नोड बन जाएगा। ये वाला लिंक हम क्रिएट कर रहे हैं, ठीक है। ये वाला लिंक, ये जो करंट लास्ट नोड है, करंटली जो लास्ट नोड है, सो इसका नेक्स्ट नोड राइट नाउ इट इज 0 बट आफ्टर द इंसर्शन ऑफ द न्यू नोड इट वोंट बी 0 बट द न्यू नोड वुड बिकम इट्स नेक्स्ट नोड। सो ये लिंक हम यहाँ पे क्रिएट कर रहे हैं, last arrow next is equal to new node and then we are declaring कि नया node is our new last node of the list, ठीक है। the new node is basically अच्छा, is the new last node of the list. Okay. अच्छा जी. So I guess this code would also work. Now let us see remove first or remove last. Okay, so we need to remove the node from the first node in the list, and we want to remove the last node. I guess its return type should also be bool. Like if the list is empty and you call this function, so you should know कि आया successfully execute हुआ ये function या नहीं. So it should return a boolean value. ठीक है. एंड यू जिस नोड को अगर आप रिमूव करना चाहते हैं तो उसकी वैल्यू आप यहाँ पे रिटर्न कर सकते हैं. यू कैन डू दैट एज वेल. ओके, सो लेट अस डू दैट. रिमूव फर्स्ट एंड रिमूव लास्ट and return a boolean value when we remove the first node or the last node. ठीक है. अच्छा, ये अब कैसे करना है? So again, so first of all, remove first. So we need to make sure कि first जो node है it exists. जो पहला जो node है it exists. ठीक है. If it doesn't, then we need to take measures. So if first is equal to null, that means the list is empty. ठीक है. So you should return false. We cannot delete any node from an empty list. Else, if that is not the case, if the list is not empty, then what should you do? So let us see, like, what should we do? So if you have to remove a list, a node or if you have to remove the first node in the list, इस नोड को से हमने रिमूव करना है तो क्या होगा? इस नोड को अगर रिमूव करना है तो होगा ये कि ये नोड जब रिमूव हो जाएगा, सो वी विल हैव अ न्यू फर्स्ट नोड. ठीक है. सो दिस नोड विल बिकम द फर्स्ट नोड. दिस नोड विल बिकम द फर्स्ट नोड. सो we should have some, like we should have this address of the node जो कि हमारा नया first node बनेगा. So we should store this address, and this address is currently stored in the next pointer of the first node. ठीक है. So one, we should store the address of the new first node जो कि बनने जा रहा है. Once we have it, so we can very easily delete it. और फिर हमने new first node का जो pointer है ना previous, उसको zero कर देना है, क्योंकि once it becomes the new first node, then it is not pointing to any other node. ठीक है. So this is very easy. All you would need is you would need one pointer to store the address of either the node जिसको आप delete करने जा रहे हैं और the node जो कि नया first बनने जा रहा है. ठीक है. So you need one pointer to store any of the two possible addresses, any of these two addresses. So let's do that. So let us declare a double node pointer, double node, and then say let us name it as this is delete me. इस नोड को जिसको हम डिलीट करने जा रहे हैं, so वो उसके एड्रेस को स्टोर करो. दैट इज बेसिकली दिस नोड. यू वांट टू डिलीट द फर्स्ट नोड. ठीक है. so उसको हमने एड्रेस यहाँ पे स्टोर कर लिया. अच्छा, so once we delete this first node, then we will have a new first node. वो कौन सा होगा? ये जो हमारा करंट फर्स्ट नोड है ना, इसके बाद वाला, यानी जिस नोड को हम डिलीट करने जा रहे हैं, इसका जो नेक्स्ट नोड होगा, दैट वुड बिकम द फर्स्ट नोड. ठीक है. दैट वुड बिकम द फर्स्ट नोड. अच्छा, so that would become the first node. Okay, and what else? Double node. Acha. Okay, so we will have a new first node, and that would be the node that comes after the node that we delete after the first node. Okay, so it will be that node. And ये जो नया first node होगा, so अब it won't have a previous node because उसको हम delete करने जा रहे हैं. So हमारा जो नया first node होगा, we need to set its previous node to null. अच्छा, we don't need to do anything else. ठीक है. यानी फिलहाल like we don't need to do anything else. यहाँ पे देखें, इस node को जब हम delete कर लेंगे, so this will become the new first node, and its का जो previous node होगा that needs to be made equal to 0. ठीक है. अच्छा, and that is what we did. So we stored the address of the node that we are going to delete, which is the first node. We declare that we have a new first node after deleting this node. So that would be the node जिसको हम delete करने जा रहे हैं उसके बाद वाला जो node है that would be our new first node. और इस नए first node का जो previous node होगा that would be 0. So now like we can delete this node that we need to delete. ठीक है, and we can return true. अच्छा, यहाँ पे एक छोटा सा प्रॉब्लम है जिसको मैं सिर्फ बता रहा हूँ, शायद में भी आपने भी सेंस कर लिया कि what would happen if we only have one node in this list. If we have a single node in this list and if you delete that node, so how would this code behave? ठीक है. अच्छा, so I want you to think about that. Maybe you'll need to make some changes. अच्छा, once we delete this node we need to update the list size. ठीक है, we need to decrement it. Once we delete a node we need to decrement the list size. So this is how we would remove the first node, and we need to do something similar to remove the last node. ठीक है, let's see. अच्छा, so we are going to delete the last node. Let us see वो हमने करना कैसे. Let us go back to the slide. For example, we need to remove this node, the last node. So once we remove this last node, this would become the last node. ठीक है, and इसका जो next pointer होगा that will be null. It won't have any node after it. ठीक है. अच्छा जी. So let's do that. So this is the node that we are going to delete. It is the current last node. So once we delete it, last node को जब हम delete कर लेंगे तो उसका जो previous node होगा that would become the new last node. ठीक है. So once we delete this node, so we'll have a new last node. That would be the node that comes before the node that we are deleting. ठीक है. It may start confusing you, but I guess it's not. And if you pay attention, and the next node for this new last node that would be set to null. ठीक है. अच्छा जी. Then we can delete this node and decrement the list size. Again, यहाँ पे भी we can have a problem if we have a single node in this list. So then we can have a problem. ठीक है. So I want you to think about that problem and how to maybe solve that problem. ठीक है. Think of ways in which you can solve that problem. अच्छा. Now we need to do traverse forward and traverse backward. So we need to basically print the list. ठीक है, doubly linked list from left to right or from first to last and from last to first. So we want to do that. अच्छा जी. So let us do that. In order to do that we need to visit each node and then we need to print the value stored in that node. So for that we need again an iterator, a pointer to a current node, a pointer to a double node. Let us name it as current, and set current equal to first because we are going to traverse from first to last. ठीक है, and do it this way: while current is not equal to null. ठीक है, so what are we going to do? So we are going to print the value stored in the current node. We are going to say cout current arrow data, and then we are going to print this thing. ठीक है, ये double pointers हैं. ठीक है, so we can move either way in the list, and sorry, that's it. That is what we want to print. Once we are done printing the list we can print an end line character. अच्छा, and before that we can print a message. Say cout visiting or traversing the list from left to right, or from first to last, from first to last. So that is how we are traversing this list. And okay, next we want to do it the other way, from last to first. अच्छा, यहाँ पे current को तो हमने modify नहीं किया. So once we are done printing the value, we can say current is equal to current arrow next. So we start from the first node and we move towards the right, in the right direction towards the last node. Achha, now let us do the other function. Copy this code and paste it here. Achha, what are we going to do here? So we are going to start from the end, the last node, and we are going to traversing the list from last to first, last to first. Sorry, last to first. So while current is not equal to 0, current arrow data, usko we print that data, and how can we do that? Okay, and then we say current is equal to current arrow previous. So let me show it to you the way it is going to happen. So first is when we want to traverse this list from first to last, so we start from the first node and then we move to the next and the next and the next, and we want to print this list from last to first. We start from the last node and we go to the previous, then previous, then previous. Okay, and that is exactly what we are doing here. Okay, so let's come to the main program and let us test our code. Let us test our doubly linked list class. So let me include the my classes dot header file. Okay. Let us create a doubly linked list. Doubly linked list. Let us call it D. Okay. So now we need to insert data into D. Okay. Or maybe we can call some methods on D. For example, we can say get first or get last. Okay. We can do that. Now let us insert some data. Let us do that in a loop. Say for int I is equal to 0, I less than 10, and plus plus I. Okay. So let us do that. What are we going to do? So we are going to insert some data into the doubly linked list D. So how are we going to do that? We are going to say D dot add at front, say add at front, and what do we want to add? We want to add this data, say I. We want to add I to the front. Okay, okay, fine. Then we want to traverse the list. D dot traverse forward. Okay. Achha. So let's check out this code. Achha ji, this is an error. Okay, let us get rid of this extra curly brace and an extra semicolon. Cool. Code has compiled fine. Let's build and run it and see if it builds and runs fine. Okay, it builds and runs fine. So we created an empty doubly linked list, and we started adding data to the front, at the front, and then we started printing that list. So initially we added 0 at the front, then we added 1, 2, there all those values appear at the front. 3, 4, 5, 6, 7, 8, 9, and this is the list. Okay, so we are traversing the list each time we add some value. Okay, let us check it in the other way around. So uh, let us do this. What should we do? Let us say d dot add at end, and let us add the value I at the end of the list. Okay, so the code compiles fine, and let us build and run it. So now we are traversing the list from first to last. So we are adding values at the last, at the end. So if you'll see that the front won't change. So 0 would always remain at the front, and the new values would appear at the end of the list. New values would appear at the end of the list. Okay. Okay. So once we are done, say let us copy this statement here. Let us do it out of the loop. Okay, so let us traverse the list in the forward direction, and then let us traverse the list in the backward direction. So let us compile it and then build and run. Okay, so this is the list. All the new entries that all the new nodes that we inserted at the front. So they are we inserted, sorry, at the end. So those entries appear at the end. So if you print that list from first to last, this is how it's going to look, and if you print it from last to first, this is how it's going to look. Okay. So now I want to do something else as well. Let me comment out these statements, and let me make some changes here. So I'm going to modify the traverse backward and forward a little bit. So I'm going to get rid of this thing. Say, let us get rid of this thing. I just want to print the data. That's it. And then here and statement here. And let us get rid of this statement as well. We don't want this to be printed either. Similarly here. And then let us get rid of this thing. Okay, so I guess this is fine now. Let's get back to the main function. Here we are going to first add d to the front and then d to the at the end. Okay, and then say I'm going to traverse the list in the forward direction. Say this is what I'm going to do, or in the backward direction. You can do it one way or the other, doesn't matter. So let's see how would the output look. So sometimes I give questions like these in the exam. So you have the data structure, and I just want to test whether you understand its behavior or not. So this would give us some interesting output, I guess, I hope. So now we have 0, 0. So we are inserting new values both at the front and at the end. So 1 appears at the front and at the end, then 2, 2, 3, 3, 4, 4, 5, 5. Okay. So it is basically a list that is expanding if you look at it from the perspective of data. So at the center of it we have these 0, zeros, and then it is expanding in the output direction. Okay. So it kind of appears like this. So this is how you can implement a doubly linked list. This is how you can implement a doubly linked list, and this is what a doubly linked list is. So it is, this implementation is slightly different than the way we implemented the singly linked list. One, the implementation point from the implementation point of view, a, a double node has three fields. One is for data, and two fields are for storing the addresses of the node to the left and to the right, or the previous node and the next node. Okay, so it is different in this way. And the other is the doubly linked list class that we implemented. Its interface is slightly different than the one that we than the interface of the list class that we used, that we implemented using the singly linked list class. So you should try both these interfaces using both these different implementation techniques. ठीक है? अच्छा जी. The next thing that we want to talk about is so this is the list interface that we implemented using the singly linked list class. You can try to implement the same interface of the list class using the doubly linked list class. ठीक है? मतलब ये methods आप doubly linked list में डाल सकते हैं. You can put the find method, the search method, the delete kth node method, and the insert kth node method. Like, you can do that. This you can think about doing some things like these. The next node that we want to talk about is the circularly linked list, or the circular list. Now, programs that use linked lists, those programs can be simplified, or their performance can be enhanced or increased if we do the following. If we convert the singly linked list into a circularly linked list, and add an additional node called the head node. So in the singly linked list, if you remember, we didn't have any node. We just had a pointer first, and that pointer pointed to the first node in the list. So first was just a pointer, it was not some node. Okay, and here we are suggesting that we add a node, head node, and that head node would be a dummy node. It would be a node object, but it would be dummy. It won't store any data. Okay, it won't store any data. So by making these two changes, uh, the performance of singly linked lists can be enhanced. Like, that code can run faster. We are not going to prove that or discuss that. Okay, but we are going to discuss circularly linked lists, or circular lists, like what they are and how can they be implemented. Okay, how can they be implemented? So whether we look at the implementation or not, I'm not sure we have enough time, but these are all very good exercises, very good things that you can do while sitting in front of the computer. Okay, so let's see, what do we mean by a circularly linked list. So this is basically a circularly linked list. How is it circular? If you look, this is a regular singly linked list. These are all the nodes. The node has an element and pointer to the next node. Okay? The only difference is that the last node in this list, it now points back to the first node. Okay? In the singly linked list, what we did was कि जब हम नए node insert कर रहे थे, the very first node that was inserted into the list, its next pointer, it was set to 0. It didn't point to anything. It didn't point to anything. But now what we are doing is we are making it point to the first node. Okay, we are making it point to the first node. So this is a circular list, or a circularly linked list, where the last node in the list, by virtue of position, this is the last node in the list by virtue of position, that node points to the first node. So this is a circularly linked list now. Okay, so now you can like move on and on into this list. You can traverse this list indefinitely. Acha. And this is the first, this is basically the pointer which points to the first node. This is the first change that we suggested. We should make the last node in this list, in the singly linked list, by virtue of position, we should make that last node point to the first node. This was the first change that we suggested. And the second change that we suggested was that we should add a head node to this list. Okay? So a head node is different. It is just a dummy node. It does not store any valid data. Okay? But nevertheless, it is a complete node object. It is a complete node object. We still have the first pointer. The first pointer points to the head node, but this head node, it basically serves as a dummy node. So the list is never empty practically. An empty list would have only the head node. An empty list would have only the head node. In this case, in the first case, case A, an empty list would have no node at all. Okay? It would have no node at all. And in this particular case, in this implementation, the empty circular list, it will have one node, and we call that node as the head node, and the head node is just a dummy node object. It does not store any data. Okay? Now what purpose does it serve? So that is also an interesting question. So all it does is it basically helps you in avoiding, it helps you simplify your code. With the head node present, you won't need to do plenty of checks के first node zero null के बराबर है या नहीं वगैरह वगैरह. तो उस किस्म के checks आपको नहीं करने पड़ते. You can write a simple code that would always work. You don't need to look for all the possibilities के इसमें अब ये your node is this a valid node or not. ठीक है? So you have one dummy node which is not supposed to store data, but इसका जो next pointer है, it is never empty. It always points to itself if there is no other node. ठीक है? And if you start inserting new nodes, so then इसको फिर हम accordingly modify कर देते हैं. So these two changes basically make the singly linked list code, the code for singly linked list, more efficient as well. Okay? That is their benefit. So if we have a non-empty circularly linked list, so it will have a head node. This is a node object, but it is not storing any data. ठीक है? इसलिए इसको हमने ये blue shade में it has been shown like that. These are all the valid nodes which store the data. ठीक है? These are not the non-dummy nodes. So again, I'm not sure, like I want to cover stack and queues as well, so we won't have any time for implementation of circular lists, but I'll try to share the handouts for the lab sessions. So there you'll find code for the implementation of circular list as well. Okay? So you can look for that. But this is how circular lists can be implemented, and circular lists can work more efficiently as compared to a simple singularly linked list, and you can also use it for some other interesting applications as well. Okay? Unfortunately, we don't have time to talk about all those applications, but that's it for now. And in the next lecture, we'll be talking about stacks, queues, and double-ended queues. Until then, Allah Hafiz.